Good morning class, good morning to all. Welcome to Jatin's Academy. Today in this class we will learn about the concept of center of gravity, which is the second part of chapter 1 force. So let's get started. So now let's understand what is the meaning of center of gravity. For this I have taken this irregular body. Now split this irregular body into some tiny particles. So here are some tiny particles of this body only. So each and every particle is attracted toward the earth because earth is attracting some mass, so that a force is called actually a weight. Means each and every particle is having their own weight. Now I am considering one center point, that is G. After that I will define this G, what is center of gravity. So now carefully see, these W1, W2, W3 are creating some movement of force. This is a force, and this is, for example, a perpendicular distance. So this is a perpendicular distance. So force into perpendicular distance creating some movement of force. So now carefully see and tell me, W1, W2, W3 are creating clockwise movement or anti-clockwise movement? So it is creating anti-clockwise movement. And W5, W6, W7 are creating clockwise movement. And what about the W4? As W4 force is on the perpendicular distance is 0 in this case, because force and this line of action of force is on the center of gravity, so it does not create any movement of force. So what is center of gravity? From this concept, what is center of gravity? So center of gravity of a body is a point. So it is a point about which algebraic sum of moment of this point is very important. Sum of moment of weight of all the particles constituting the body is 0. It means that each and every particle is creating some movement of force. So this movement of force, which is clockwise and anti-clockwise, the sum of all movement which is present inside the body, at some point that must be 0. For example, if I am taking center of gravity at this point, then the sum of moment of force about, or sum of moment of weight about this point is not 0. So this I am not considering a center of gravity. I have to consider a center of gravity at that point where the sum of movement, means sum of anti-clockwise movement and sum of clockwise movement, must be 0. We know that anti-clockwise movement we are taking as positive and clockwise movement we are taking as negative. So when negative and positive counterbalance each other and answer will become 0, that point is called center of gravity. And one more speciality of this center of gravity is that the entire weight of the body, this small particle, entire weight of a body, I can consider at one point, and that point is again called center of gravity. So here weight is acting. So this weight is sum of all the particles, W1, W2, W3, sum of all the particles which is present inside the body. So center of gravity, two things we have seen. First of all, the algebraic sum of moment of weight of all the particle which is present or constituting the body is 0. And second, we have to see the entire weight of the body can be considered to act as this point. So these two definition mix up and forms the definition of a center of gravity. Next we have points to remember, very important points. First point we have, position of center of body of a given mass depend upon its shape, that is the distribution of mass. Now what is the meaning of this? Carefully see. For example, if we taking the distribution of mass, center of gravity depend upon the distribution of mass. Now tell me, out of A region or B region, where mass is more? So we can see in the B region mass is more. So center of gravity is more toward the where distribution of mass is more. Where mass is more, their center of gravity position is more. So if, for example, if I am having a regular surface, so for the regular surface, distribution of mass is equal in each and every point. It means that the center of gravity is at the center. So geometric center and the center of gravity is same, because distribution of mass at each and every point is same. But for irregular bodies, distribution of mass is not same. So as distribution of mass is not same, so the position of the center of gravity will change. Okay, for example, I have this body, I have this irregular body. Its center of gravity is like this. Now if I change the shape of the body, if I change the shape of the body, the center of gravity will also shift. It means that the center of the gravity will depend upon the distribution of mass, how the mass is distributed. Next we have, it is not necessary that the center of gravity always be within the material of the body. For example, we have one bangle. Okay, so for the bangle, here we have a material, but where is the center of gravity? So let's find the center of gravity of this bangle. So for this we have to take one thread like this and another thread like this. So intersection of these two threads, this point we got as a center of gravity. So here if you will hang the bangle, only then the all movement of weight is zero. This is called the center of gravity point. But this point is to outside the material. It means that it is not necessary that the center of gravity of a body is always be within the material. It can be outside the material also. Next point we have, by the concept of center of gravity, a body of weight W can be considered as a point particle of weight at its center of gravity. Now what is the meaning of this? Carefully listen. For example, this body is made up from tiny particles, okay, and this tiny particle is having their own weight. So we have to consider one point where the whole weight of the body I can consider at one point. So where is that point? That point is called a center of gravity. So center of gravity is a point where I can consider the whole weight of this body at one point. So that point is called center of gravity. Next we have center of gravity, some regular objects. So we have to remember this also, that what is the regular object and where its center of gravity is. So first we have circular ring is having center of gravity is at its center. Circular disc also having center of gravity at center. Next is important, triangular lamina. Triangular lamina having center of gravity at the point of intersection of their medians. Okay, so we have to take their three median. What is a median? So this base is having some midpoint. So from midpoint to vertex, whatever the line we are getting, that is called median. So intersection of these median, we got a point that is called a center of gravity. Next we have a rectangular or four-sided figure, quadrilateral. It is an intersection of their diagonals. Next we have parallelogram, again four sides, intersection of their diagonals. Last we have a solid or hollow cylinder. Solid or hollow cylinder, we have a axis, the midpoint of the axis. So for example, this is a cylinder. Okay, so this cylinder is having some axis, okay, symmetric axis. So the midpoint of this symmetric axis, we got a center of gravity of a solid or hollow cylinder. Next we have hollow cone. For the hollow cone, we have two things, apex or base. So from the base, we got a center of gravity for a hollow cone, that is h by 3. And from the base for the solid cone, we have h by 4. It means that from the apex we also have to remember, subtracting it from h, we got from the apex center of gravity is 2h by 3, and here we got the center of gravity from the apex is 3h by 4. And last we have a sphere. Sphere is also having either it is a solid sphere or a hollow sphere. We got the center of gravity at the center of the body. So here are some the center of gravity of some regular objects. Next we have center of gravity and balance point. For example, I have one meter rule. Meter rule means 100 centimeter rule. So if it is a uniform meter rule, So it is balanced at its midpoint, which is a 50 centimeter, for example. So solid body can be balanced by supporting it at center of gravity. So for this regular body, this rod center of gravity is at pure center. Okay. Now for example, if I'm changing the distribution of mass, how I'm getting changing the distribution of mass, carefully see. If I place one object on one side, so where the mass is more? For example, this we have a left side, this we have a right side. Okay. Now carefully tell me where the distribution of mass is more, on left side or on right side? Obviously we have placed the ball on the left side, so distribution of mass on left side is more. So in order to balance this means in order to balance this body, now we have to place, or the center of gravity is going toward the mass, means more is the mass at that point, more is the distribution of mass, so center of gravity will attract toward the more distribution of mass. Okay, so here it is, now the new center of gravity is toward the region where distribution of mass is more. Next we have how to find the center of gravity of irregular lamina. So irregular lamina center of gravity we can find with the plumb line. So this is actually a plumb. So we will make a plumb line. How we will make? We will make some 3 holes on a body. After that we will attach this plumb. Okay, we will attach this plumb like this, and we will draw the lines. So we will draw first horizontal line here. Okay, so this is first line I have drawn. Now rotate this irregular body. After rotating, again draw one line. Okay, again rotate this. After rotating, again draw one line. So the intersection of these lines on an irregular body will give us the center of gravity of irregular lamina. So the procedure now it's clear to you how you will calculate the center of gravity of irregular lamina, just by making a plumb line, horizontal line at different position. The intersection of these lines, you will get a center of gravity of a irregular lamina. Note point we have, for stable equilibrium of a body, its center of gravity must be as low as possible. It must be above the base and near the geometric center of the body. Now carefully understand this note point. We have basically 3 types of equilibrium: stable equilibrium, unstable equilibrium and neutral equilibrium. Here I am talking about the stable equilibrium. For stable equilibrium, the center of gravity must be as low as possible and near its geometric center. Means, for example, this is a regular body triangle, we have a geometric center, for example at this point. So the center of gravity must be as near as possible and it must be above the baseline. These 2 conditions must be satisfied for a body to be in a equilibrium, that is a stable equilibrium. Otherwise the body can be in unstable equilibrium. And for neutral equilibrium, the center of gravity and the geometric center is at a same point. Okay.